So today we're gonna go through the materials on exam 2. Right now we are doing estimation. So before we are actually getting into estimation, let's put this concept into the whole class, right? So there are two things here. So so here is population and this is sample. So from population to sample, we do sampling, and from sample to population, we do statistic inference. So for the sampling stuff, this is where all the probability gets into play, and this is the sampling distribution, when we're learning it. And this basically covers the first part of this course, the things in exam 1, and from sample to population, that's called statistical inference. This is, I think, this part is the one on exam 2. Yes, so for population, we're using population parameters like population mean, mu, and population variance, sigma square. And for sample, we're using statistics like, okay, so this is population mean and population variance, that's sigma square. And so for sample, we're using statistics like the mean is x bar and the sample variance is s square. Should be small s. Yes. Okay, so there are two estimation you can do. One is point estimation, one is interval estimation. So for point estimation, the main thing is we want a single estimate from the sample. We're gonna have a single estimate to say, well, this is the best we can do to estimate population mean. And for for interval estimation, our goal is to obtain a range of possible values to say, well, this is the best we can do to estimate the population mean or population variance. Okay, so here is something. So what is confidence interval? Sometimes you get confused about this kind of concept. So confidence interval. So relationship with confidence interval and point estimate. What is point estimate? That's the sample statistic. So let's go back to a slide. So this is the sample statistic, right? We have the x bar, and this or the s square. Both of them could be point estimate. Okay, so point estimate, it's sample statistic. So point estimate is sample mean like x bar or sample proportion like p hat. And so confidence interval is constructed using your point estimate. So that's why we are doing the x bar plus or minus something and p plus or minus something, and right? And this confidence will always center around the point estimate. And so the length of the how long this confidence interval is gonna be depends on alpha level, standard error, and sample size. So these three things, like alpha here, and this one, and standard error, this you can't calculate standard errors with this one, and standard error, and then sample size, that's n here. So that's the thing, it's gonna affect the length of the confidence interval. But this number, like x bar or p hat, it doesn't really matter, because if x bar change, it's just gonna change where it is. It's not gonna change the length of the confidence interval. Okay, and then the relationship between confidence interval and the population parameter. So here, population parameter is something we want. We want to estimate the true population parameter. Like this is the mu and this is the p. There's no hat or no bar here. So estimate true population parameter. So 95% confident interval refer to an interval where we are 95% confident that the true population parameter lies. And make statistic difference for decisions for hypothesis testing. So we reject non-hypothesis if hypothesized population value is outside the confidence interval. So let's go back to one side. This point estimate is what we get from the sample. And this population parameter is what we want. So let's go back to this one. So this is something we have because we can always calculate this kind of stuff from sample. And this is what we want. So because we have it, this is already a point estimate. And there is a point estimate here. This is a point estimate, and we gave it an interval. That's the point estimate, and this is the confidence interval. And we want to use this tool to estimate population parameters. I will post all the slides. Yeah, and okay. And then for further calculation, just refer to Yinqing's recitation slide on page 4 to 15. Okay.